JLJ Effluent Engineering Limited, a division of the JLJ Group of companies, are leaders in the design and installation of industrial effluent treatment plants using rotary vacuum drum filtration technology. The company has been developing their expertise in this field since 1992 and are renowned in the UK and Europe for creating effective systems that treat harmful industrial effluent, making it more manageable and safe for disposal. Their latest system is the JLJ Euro 9018. It incorporates their latest in engineering and electrical technology and marks a major step forward in the separation of suspended metal contaminants from liquid, which are found in many kinds of industrial effluent. The resulting solids can safely go into landfill without the danger of seepage, and the filtered liquid can be recycled around the factory or flushed to the sewers if necessary, as it comes well within the EU environmental regulations regarding the quality of water disposal in this way. It's a system that will make a major contribution towards safeguarding our environment and, at the same time, making savings for certain manufacturers. As an example, this multinational packaging manufacturer uses a large volume of ink to print on its paper products. This requires a printing press washdown each time the colours are changed. Consequently, 5 to 6 kilos of ink are wasted each time. The resulting watery effluent contains all the toxic metals and colours from the residual ink, and it has to be disposed of safely. The JLJ Euro 9018 provided this company with the most effective environmental solution. So, how does the system work? System overview. The first stage is to fill the chemical treatment tank with the industrial waste or effluent held in the bulk storage tank. We then add the chemicals one by one to meet specific pH set points. The chemicals in a standard process normally consist of ferric sulfate and lime. This will adjust the pH in the effluent waste, causing coagulation which precipitates the heavy metals from the water. Whilst this is all taking place, the fluid is being transported via the pH pump, which is continuously pumping the fluid past the pH sensor, all the time returning the fluid back to the chemical treatment tank in a closed loop. During this stage, we are continuously introducing chemicals. These are delivered to the effluent through these flexible hoses, which minimize human contact with the chemicals. Because we're taking the fluid from a very low pH to a very high pH, the system at this stage uses these polypropylene pumps, which are corrosion resistant. Once precipitation has taken place, the system will automatically transfer this fluid to the filtration feed tank. Here it is kept agitated until such time we need to send it through the filtration system. The next part of the process happens here at the filter aid tank, which has to be filled with water. We can see this clearly on our scaled down working model of the system. This is a sample of effluent ready for filtration, and here the filter aid or pre-filter media powder has been added to the water in the filter aid tank. The mixture is agitated for 20 minutes before it's released to the filtration pan, here below the rotating vacuum filtration drum. The high vacuum inside this filtration drum draws the mixture through the ultrafine outer filament, thus adhering the filter aid in a thick white coat evenly around the outside. The vacuum inside the drum is constantly maintained by this large vacuum pump, which draws water from the vacuum pump's seal water tank in a separate closed-loop system. This incorporates a heat exchanger to keep the circulation cool, saving on costs as no extra water is required. The residual clean water, drawn through the filter media into the drum, is constantly being pumped out of the vacuum vessel. From here, it's recycled back to the filter aid tank via the receiver pump. Again, this saves on the cost of water, as there is no need to refill the filter aid tank. When sufficient filter aid has adhered to the drum, the waiting treated effluent agitating in the filtration feed tank can now be pumped into the filtration pan by the filter feed pump. Now the process of filtration can be clearly seen. The white filter aid turns a dark grey, almost black, as the toxic solids and metals are collected in a layer on its surface. The metal deposits and colourings are sliced off the surface of the filter aid by the horizontal blade running the full length of the drum. The system fractionally steps the blade forward on each rotation, so that the effluent always has a clean filter aid surface to filter through. This process continues until the filter aid needs to be replaced or the chemically treated water has run out. The resulting solids produced by using the JLJ Euro 9018 filtration system can safely go into landfill. Unlike a lot of other processes, the solid waste this system produces is very low in moisture, typically around 30%. Because we've taken the metals out of the solution and put them back into solid form, they will not go back into dilution, therefore making them safe in the ground. This is in total contrast to filter press machines used for the same process, which produce waste with a moisture content of 85%. During the filtration process, the filtered water from the effluent, which collects inside the vacuum filtration drum, is drawn out to the vacuum vessel. From here, the receiver pump sends the water to the filtrate inspection tank. Here it can be pumped out in 3 directions via valves, either into the drains or into the filtered water storage tank for recycling, or back through the system for further treatment. A comparison can easily be seen between the heavy metal effluent before filtration and the clarity of the filtered water after processing. And as mentioned, it comes well within all the EU environmental regulations regarding the quality of water that can be disposed of into the sewers. The main advantages of the JLJ Euro 9018. The quality of the resulting filtered water is such that it can be used again in the client's process or in washdown between each session. The low moisture content of the filtered solids means there is less tonnage to go into landfill, which reduces the cost of disposal. The complete vacuum filter system is modular, meaning it is pre-piped and pre-wired, very adaptable, easily moved from A to B, and installation is quick due to its design. It's a fully automated system. The touchscreen control panel is user-friendly, and the state-of-the-art electronics incorporated monitor everything that can be monitored throughout the process. It doesn't have to be manned permanently, needing only 1 hour's attention per day. Again, this is a complete contrast to the 5 or 6 hours a day needed to man a filter press. The only thing the operator has to do is to put in the bags of filter aid, then press the button to say go. From that second on, it is fully automated with a programmable logic controller controlling the chemicals and the speed of the drum in a step-by-step program that goes through its process of filtration methodically. We offer a full service contract to our clients. This usually comprises of 3 to 4 visits a year, within which we do a health check, a tune-up, and issue a report on the condition of the machine and what they need to do before our next visit. Should an engineer be needed, we have a